In the second part for our marble ball game today, we are going to see the two new ideas. We are going to get introduced to a concept of using not the entire sketch, but the closed segments or closed areas of the sketch to create a part, as well as to a concept of the hole wizard, which allows us to automatically create circular holes and slots, not using the cut command. In general, anytime we have a circular hole that should be drilled, counterbored, countersunk, or if we have a slot, it is a bad idea to use the cut, because if you are going to process the part after in a CNC machine, if you are going to process it in a Mastercam or into SurfCam or into any of the CAM softwares, most of the time the cut is not going to pick up as a drill cycle. If it is an extrude cut, it will be pick up as a pocketing, as a GO2, GO3 operation versus the G80 something, G81 cycle or whatever it is. So, however, if you use the hole wizards, what happens, the file will be in the subsequent step file that you may save for your CAM system will be annotated in a way that actually CAM knows that it is a hole and will use the, and will in the automatic toolpath generation use the proper commands. So that's very important. Although on the model on a screen is not all the time displayed. So it's not something that is so obvious, because on your screen in a CAD, if you do the hole, let's say of 16 millimeters as a hole, or let's say of 10 millimeter hole as a hole, or if you do the circle and do extrude cut on the screen, it will look the same. However, every time you have a standard holes, you should use the hole wizard, because otherwise it does not have association of being a hole. So, in this particular part, let's set up materials again. So we hover over material, right click, and then we go to edit material, left click on edit material, and we will choose again the same wood. So we go to a wood, and I believe we use the beech, apply. And now we are going to make the part number 2. And that part lives on the right plane. It's oriented towards the right plane. So I'm going to press on a sketch tab, with the left button of the mouse, on the sketch icon, and I will choose here right plane, again, left button of the mouse. And this opened my right plane for sketching. Now, looking at this part with those two holes, what I'm going to do, obviously, I will not put the hole in a primary sketch. I'm going to put them as a placed features, as a holes. However, those stubs at the bottom, which allows this part to be inserted into the base part which you previously created, we are going to do it a different way. We are going to do with the intersections of lines from a different rectangles, and then when we extrude, we are going to choose which areas we want to be extruded, which closed areas want to be extruded. So we will start here by making a rectangle of 54 by 70 millimeters. So be sure that we are in a MMGS, so we will switch to the units to the millimeters, and we will reopen the sketch, the right plane, place the rectangle, two-corner rectangle, again hover over the origin, stretch it out arbitrarily, press escape to terminate command, click on it with the left mouse button on a smart dimension, place the horizontal dimension by choosing two vertical lines with the left mouse button and specify that this distance is 54 millimeters. And now specify vertical distance, the distance by choosing two horizontal lines to be a 70 millimeters. This will give us the outline. Now, we can create those two tabs in the same sketch in the two different ways. If we use a command which is called trim, we will need to do some additional definitions because we will break some of the lines. However, instead of the trimming, which should be only done when absolutely necessary, we can go the different route, which is the most efficient route, and that's to choose the different areas of the sketches. So, if I make a rectangle, the corner rectangle, so left click on corner rectangle, anchor it on the lower right corner, and stretch it up to be coincidental with the top horizontal line, and then put the dimension of 4 for the thickness. And now, if I create two rectangles, coincident, and as you can see, because we use the relationship of coincidental and horizontal and vertical, this is still fully defined. So we did not need to enter again that this line is in a height of 70 millimeters. Why? Because it was inherited, because distance between those two lines are 70, and because the edges are coincidental and it's a rectangle, it automatically inherits that relationship. So now what I'm going to do, I'm going to make a rectangle as a corner rectangle, starting somewhere coincidental on the inner line and ending somewhere coincidental on the outer line, and likewise another corner rectangle this time, or I will actually just leave this as is, and then I will use the mirror in a sketch mode to show you that you can actually do the mirrors also in a sketch mode. And we are going to dimension the length or height, better to say, of this rectangle to be 10, and the distance between the top of the line and the top of the rectangle to be another 10 millimeter. Now, I can either repeat the same, straight to it, I can either repeat the same operation here, or I can use the mirror command in a sketch mode. The difference is that the mirror command in a sketch mode works at the 2D, and the mirror in a two-dimensional world is what? Is not a plane, now will be a straight line. So I will use the straight construction line. This icon here on this pane is the line icon, and if I click on the arrow, I can see that there is an option which is called center line or construction line. I left click on a construction line, I hover over the midpoint and go to the opposite midpoint. It's horizontal, press escape to exit command. This will be my mirror. Now, all what I have to do is to click on the mirror entities with the left mouse button click, and click on the entities to mirror. I only want these two lines, so entities to mirror, and I want to have this here button copy to have a check mark, actually that area to have a check mark box to have a copy, and I will choose entity to mirror line 9 and line 10 of our rectangle, and then I'm going to hover over mirror about, press the left mouse there, and click my mirror line. And look what happened. It shows me the two newly created geometries in the yellow. And the moment I close this command by clicking on the green OK, it will appear here. Now, this is kind of a complicated sketch. So what I want to do now with this sketch, when I extrude it, I will choose this area here and only area inside the tabs. I will not choose the entire sketch. And I will extrude it and will create a single extrude. So, okay, I close the sketch by clicking on the check mark, on that icon next to them. And now I click on a feature pane. I click on extrude boss base. I'm going to place 4 millimeters. 4 millimeters. And now I'm going here, you see the option which says select contour. Instead of clicking on the entire sketch, I'm going to hover over the blue area of the box next to under select contour, press left button of the mouse to activate selection, and now choose all the areas that I wanted to become a solid. So I will move here, I will choose my big rectangle area and my tabs. And as you can see, I'm not bothered with other constructive geometries, which stays there. I click OK, and here is my base feature. Now, on the top of this base feature, I need to place those two holes, which are going to be a 16 millimeters hole. I'm going to use for the first time a command called hole wizard. Hole wizard lives here. Yes, so hole wizard. Let's click on a hole wizard. And here now we have all type of holes that we can use. And then we will go there to the two panes. The one is choose the type of the hole, and we will go over hole wizard in much more details 3 classes from now. This is just a demonstration of basic hole wizard. And then we have a position. Here is a standard. So let's see if we click to the ANSI, left click on the mouse. From ANSI inch, we want to go to a metric standard. And type of the hole, we just want to have a straight through hole. Hole size M16. And fit for this wheel doesn't matter, normal. So there is a 16 millimeter standard hole. And then you click, after we choose the standard hole, we click on a position with the left button of the mouse. And we click on the face of our newly created plate. And we will go back to the type, because this was not the right hole type. We want to have a simple hole, so we change it just to the double hole. And the size we need to check back to a 16. So, because this was the countersunk hole that by error we chose before, so we choose the simple hole. And now we go position. And I place one here and one here. And I press escape. And now all what I need to do is to define the position of this hole. And if I look how it looks like, actually the first one will be from this edge, 15 millimeters from the top, from the side edge, and vertical 15. And now the second one will be 15 millimeters from this edge, from the bottom edge, and vertical from the bottom edge, again 15. And that fully defines our plate. We will save this plate as a save as command, file save as, and we are going to call it, instead of the default part 2, we can call it the target, and the previous one we should call base. Okay, well, this completed creation of our parts. We can check all the annotations that they are correct by clicking annotations, right click on it, choose display annotation, and show features dimension. And here are all of the dimensions. Now, in the next exercise, we are going to create an assembly of the two parts, and then we are going to create a drawings, and that will complete the demonstration of the basic workflow of constructing projects, of constructing anything in a SOLIDWORKS, where we first make the parts, and then we will make the parts into the assembly, and then also create the drawings for fabrication of the parts.